So let's start with the port X data register. Now this register sets the value to the corresponding port. Now a pin be output or a input. If port X is written logic 1, when the pin is configured as an input pin, the pull-up register is activated. To switch the pull-up register off, port X has to be written logic 0 or the pin has to be configured as an output logic pin. The ports pin are tri-stated when a reset condition becomes active even if no clocks are running. So when switching devices between tri-state, output high and intermediate state with either pull-up enabled or output low must occur. Normally the pull-up enabled state is fully acceptable as a high impedance environment with no notice the difference between a strong high driver and pull-up. If this is not the case, the PUD bit in the SFIOR register can be set to disable all pull-up in the all ports. So let's see how the output works in a port. So this is an output pin. If a pin is set to be output, then by setting bit 1 we make output high, that is 0.5 volt, and by setting to bit 0 we make output low, that is 0 volt. So DDR-D is equal to 0 cross FF, that is all the pins are right now output, as I have told you earlier in the data direction section. Now we want to set output as, suppose we are working on port D currently. So in the port D we have PD7, PD6, PD5, PD4, PD3, PD2, PD1, PD0. It means port D is a 8-bit port. Now suppose I want to make PD7 as high, PD6 as high, PD5 low, PD4 low, PD3 low, PD2 high, PD1 high and PD0 low. Means in the port D my values are 11001100. Means for setting up the output pin I have to give a data direction this one and my port value should be this. So in this way I can set the value or the function behavior as a high or low. Next is a input pin. So in the input pin, if a pin is set to be a input, then by setting its corresponding bit in port X register we make it as follow. If set bit 0 means tri-stated, if set bit 1 means pull-up state. So tri-state means the input will hang if no input voltage is specified on that pin. Pull-up means input will go to plus 5 volt if no input voltage is given on the pin. It is basically connecting pin to plus 5 volt through a register. Means whenever there is a pull-up register, means the bit is set to 1, it automatically gives the plus 5 volt and you can directly connect any kind of LED or something other component to that pin. Suppose this is a pin of your microcontroller, so I am directly connect one LED over here and make it ground. So in this way I can connect the register and LED, because this port is a bit high port, bit 1, so it is plus 5 volt which is feasible to run the LED. So in this way you can set the input and output of the port. We are now going to learn about the pin, means data read register. Pin is actually used to read the data value on that pin right now. So suppose this is our microcontroller and this is the pins we have. So we have given plus 5 volt on that pin, 0 volt on that pin, plus 5 volt on that pin. So to read the values we have to use a register, means which will read the values on that pin. Means on that pin voltage is high, on that pin voltage is low or no, or in that pin voltage is high or no. So this register is basically used to read the value of a port. If pins is set as input, then corresponding bit on pin register is 0 for low voltage, means voltage should be less than 2.5 volt. 1 for high input, means the voltage should be greater than 2.5 volt ideally, but in our cases we will take the voltage as 3.3 volt to up to 5.4 volt. Consider we have connected a sensor on PC4 and configure it as an input pin through DDR register. Now I want to read the value of PC4, whether it is a low or high. So I just check the 4th bit of pin C register. So if I check the fourth pin of the pin C register, it automatically checks whether it is a high or low. So one note for you, we can only read bits of the pin X register, can never write on that port. Means whenever you are reading any pin, you cannot give the same pin as an output through port. If you have a microcontroller and this is port C and this is port D, so suppose you are taking any kind of input from port C pin 1, so and you have already connected one LED also here, so simultaneously you cannot do the both the things at the same time. So in this way you can read the values using the pin register. This is needed to avoid metastability if the physical pin changes value near the edge of the internal clock. This is a way you can use the pin.